Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Tuesday, December 9th, 2025. 3D-Printed scaffolds for new blood vessels. WPI researcher Yonghui Ding's work points to a new approach for heart bypass grafts. The tiny opaque tube that Yonghui Ding holds up to the light in his laboratory looks like a bit of debris from a dismantled ballpoint pen. Just 1 centimeter long and about 2 to 3 millimeters in diameter, the biodegradable tube is too small for the grooves and channels on its surfaces to be easily visible. Yet those microscopic textures represent an advance that Ding, an assistant professor in WPI's Department of Biomedical Engineering, thinks may someday lead to big improvements in heart bypass surgeries. In a new paper in the journal Advanced Healthcare Materials, Ding and research collaborators from Northwestern University reported that they developed a rapid 3D printing process using biodegradable ink and light to produce tubular implantable scaffolds with grooves and channels. The textures created pathways for cells to migrate across the implant surfaces and line up with each other, a critical step in regenerating blood vessels to the heart. The goal of this research is to regenerate arteries, not just replace them, says Ding. To achieve that goal, it will be important to develop grafts that temporarily provide the structure for tissue growth and enable new cells to grow into healthy and functional blood vessels. The research aims to improve surgical treatment for one of the nation's leading public health challenges: heart disease. The leading cause of heart attacks is blockage in the vessels supplying blood to the heart. A common surgical treatment is coronary artery bypass grafting, which involves attaching a vein or synthetic tube to reroute circulation around a blockage to restore healthy blood flow to the heart. To improve grafting procedures, the researchers have focused on building better temporary grafts. Their work has revolved around a novel process of multi-scale microscopic 3D printing. Using a specialized 3D printer built in the Ding lab, the researchers deposited layers of liquid polymer onto a flat plate to carefully build a tube, layer by layer. They also used ultraviolet light to project patterns onto the tube as it took shape. The citrate-based polymer was then cured into a flexible and biodegradable material. Patterns on the tube surfaces created routes for endothelial cells and smooth muscle cells, which are found in blood vessels, to move and line up with each other on the tube surfaces. In a head-to-head comparison, the researchers found that endothelial cells migrated and lined up better on textured scaffolds than on smooth scaffolds. In addition to Ding, WPI, authors on the paper were PhD student Rao Fu, postdoctoral fellow Ni Chen, research scientist Biao Si, and Zhenglun Alan Wei, assistant professor in the WPI Department of Biomedical Engineering and an adjunct faculty member at UMass Chan Medical School. Authors at Northwestern were Guillermo Amir, professor and director of the Center for Advanced Regenerative Engineering, Professor of Mechanical Engineering Cheng Sun, PhD student Evan Jones, and master's degree student Bo Yuan Sun. The research reflects Ding's focus on the design and manufacturing of biomaterial scaffolds for the regeneration of tissues, such as vascular and musculoskeletal tissues. He joined the WPI faculty in 2023 after serving as a research assistant professor at Northwestern, and his research has been funded by the American Heart Association and the National Institutes of Health. I'm really excited about translational research that breaks ground scientifically, but also has the potential to improve people's lives, Ding says. Many people need bypass surgery, and our research could result in better grafts that lead to better health outcomes for patients.